very excited to present Dr. Julieta Aguilera. She has a PhD from Plymouth University in the United Kingdom, and she has a lot of experience with planetary visualizations. In fact, she also worked at the Adler Planetarium on the big dome and the visualization lab. And today she's going to talk to us about her work.
So just to tell you a little bit about me, I studied design at the School of Architecture in Chile, um, in Valparaiso, in the city of Valparaiso, which is very much rooted in the Bauhaus. And in this school, we did things like body culture, where we build uh, structures and then we move with those structures. So they kind of modify our body and how we move through space. And that affected my career a lot. Being a designer, I felt like I was free from the constraints of that architecture has to create solid structures that don't change, and have me focus early on interaction. And we also had lots of mathematics classes in a very abstract way. So I think that also made me less scared of mathematics, like you would say some people maybe. Um, and I really enjoy it. And I did come to the US to extend my design career. And in doing so, um, I did two Master of Fine Arts, one at the University of Notre Dame. And then after meeting people from EBL, I started uh, the MFA, a second MFA at EBL. And it's in that one that I work on the cave. So my first MFA, I wrote about virtual reality, doing QuickTime VR, very simple ideas. I took film classes and interaction classes, but then I wanted to work in the cave. And when I was studying at EBL, I took a math class with Luke Kaufman, and I was thinking, what do I do that an architect cannot do? Something that changes over time and something that reacts to your body. So I asked Lou one day, it's like, could I make a grid in higher dimensions? And he's like, oh yes, of course, do polytopes. So he told me about the book, and I look at the book, and my husband helped me with the programming, because we had to write the whole code from scratch, since the cave was for 3D graphics, not 4D graphics. So what you're seeing is a three-dimensional shadow of a four-dimensional grid. And the way it worked, I just had it evolve with different textures, but you see that both arms, with one hand, I'm rotating the structure in 3D, and with the other hand, with the other arm, I'm rotating the structure in 4D. And I wanted that sense of feeling like you're wearing a space, like if you're in a city and the way you move kind of rearranges the buildings a little bit. So that was the interest, like what spaces can we create that are not the human experience of being on these spaces that we're in our rooms listening to this talk. Um, so that's why I took the job at the Space Visualization Laboratory. And you see here is just a time lapse, but showing all the many devices that kind of affect the senses and the body in different manners. So we had touch screens, touch tables, a stereoscopic screen over here, high definition panel display here that was responsive to the body with a Kinect. And overall, just different things that map differently to your body. We also had Oculus. Um, and I worked at the Adler for 8 years. So that's a lot of what I present is that experience. So I joined this PhD program halfway through my tenure at the Adler to kind of compile all these experiences and thoughts. So this is one of the illustrations I had in the thesis, which ultimately want to point out to how we inhabit bigger scales through models and through sensors and devices, but our personal experience is very limited as to what our body and our senses and our ability to move can reach. Um, but we inhabit models of what a city is when we want to navigate through a city in our minds, not necessarily Google. Uh, we take a road trip, we have a model of where we're going. We kind of know which way to turn and so forth. And the planet, we're seeing images of our planet, uh, through the International Space Station, or we see models in the planetarium, and everything else is a model. It's not a direct experience that we are capable with our own body. So um, that's a little bit in the direction I'm going. So early on, also I was looking into how we are not just one device. We have different sensors and different capabilities to move, to feel things, right? Um, and of all of them, only sight can escape the Earth's atmosphere to see stars, but everything else needs the atmosphere, and it needs a certain distance. If it's going to be touchable, it needs to be arm's length, and temperature and so forth. The chemical senses, taste, smell, that some people are losing now with COVID. All these have a different range. So we are very particular in how we are structured as human beings, and I reflected a lot on how that alone is a very interesting point in understanding ourselves and our biases and whatnot. And of course, with VR, we are in a situation where we have this experience of being inside in a much more obvious manner. So what does it mean? Before, we could see different media in front of us and move around, structures and so forth, but now we can be inside. And alas, we are inside the universe. So that's an important aspect. And my advisor, Roy Ascott, asked me early on, so, tell me, give me a tell me how the structure of that being there is, what affects it. So I look into these aspects of depth, on how we perceive depth, how much is that we afford perceiving, how much is that we can interact through the motion of our body, and what gives us the sense of being inside, from that kind of a spatially subjective manner. And then this is a couple of little models that I saw at the Museum of Science in London that represent the human body, and how, how many resources from the brain the senses take, and the motor system takes. So you have hands taking a lot of senses, touch, and also handling. So you have huge hands. A lot of our brain is devoted to our hands, not so much to our feet, apparently. And of course, taste, because we don't want to poison ourselves. Uh, and eyes, of course, very, very important. But you see the model on the right has no ears, because we don't have the capability like other animals do to move our ears and respond to the world with ear movement. Um, so we have this configuration of our body, and it's interesting when you study through all this technology that has, VR, that creates all this sensory input to your body, but then the body in itself, it has a structure that is not particularly modifiable. Um, so one of my colleagues in the planetary uh, her name is Laura Beloff, and she was doing devices that extend the human body. So she had made this tail, like a horse tail, that connected uh, to your brain, to the signals of the brain. It would move in different ways to reflect something of what was going on in your brain, as another kind of expressing uh, what was going on. And she was reading this book on Jacob von Uexküll. So he wrote about a century ago about the world of animals and, of course, men, women, species, human species in that sense. So here we have this room where for uh, a human will read the books, would sit at that table, uh, would dine, would sit at the table and read some letters, or would sit at this table and have lunch, or sit over here and uh, rest for a while. So this room is very accessible to a human being, right? Uh, but for a dog, for the world of a dog, this is a very different world. So you have that for the dog, uh, the chair is very important to reach the food, to jump and reach the plates and the cups. And the couch and the other chair are very important because it can, it's comfy. The dog can jump there and take a nap. Uh, if we look next to it, you have the world of a fly, where for the fly, of course, um, the fly would be, flying around the lamp and have some fun looking at the light, uh, or reach the food, the plates and the cups. But for the fly cannot care less about the bookshelves and the writing letters. So we do have these particular structures that are different, that determine what we pay attention to. Um, and of those experiences, we do, since we're here, born and raised on planet Earth, we carry this configuration of how the world works. And we carry all our senses. You could think, oh, well, I can see, I'm going to design this experience to be purely visual, but whatever you present visually will recall all the other senses with the connections that vision has to them. Um, and of course, who studies perception and what happens in the mind is artists seeing what happens when you feel the world in all these different manners. Um, so Jacob von Uskul also had this at the end of his writing that said, of all human, the astronomer has the biggest world of all because it can extend its senses as far as it possibly can with the tools that humans build. So we have the situation that we are extending our senses. So not only we have a body, but we are extending the body with what we can see and do in whatever environments. And I wanted to bring also up the situation of VR, whereas not just looking at something, or not just looking around what is happening now with the devices we have, but we can create scientific visualizations or any kind of experience where we can move through space. And Dan Sandin, who was the director of EVL, he said this is like the first redefinition of perspective since the Renaissance, that your perspective accompanies you. Is not uh, this this little point that defines how this person looks at this figure in the other side of the room. So you have this redefinition of perspective, this moving point of view in understanding how this being inside happens. Um, and of course, we have this model of interaction, which is you do something happens, right? Uh, but what may happen if any of these parameters changes is, it needs to be defined. You do have not just things being larger or smaller or close or far, uh, or that happened in the past and are going to happen in the future, but you have different scopes and spans in all these variables. And that's what I want to introduce in terms of space, that, there are big ranges, huge ranges. That's why I took the job at Adler. I wanted to see what was going on with those ranges. And then one day I realized, well, we're looking at all this visualization in stereo, but what you do when you put an a comet. This was the one from the Rosetta mission. Um, when you put this comet in a stereo in front of a person, that means to a person that the comet is about 12 feet away or something like that, and of course in the lab, the time lapse that I was showing you with all those devices and things happening, we had the geo wall that was created in EVL in the back of the room, and people, not just kids, whenever we show something in stereo, they would go and try to grab it because it was reachable. It feels very tactile. So you get the senses being recalled to say, oh, this is actually close to me. Of course, that would happen in the cave, but to see it in people that had never experienced VR, it was pretty interesting. Um, but then, of course, we have the situation where there are senses, their capabilities, senses that we don't have. We can only afford a little bit of the magnetic spectrum, electromagnetic spectrum, which is that little tiny little bit of the electromagnetic spectrum. You don't see microwaves, you don't see X-rays or gamma rays or whatnot. And then we are looking into space with tools that detect gravitational waves, which we give for granted because we're on planet Earth. So unless you're an astronaut floating in zero gravity up in the sky, you would not pay attention to gravity as to feel it in your body. I mean, you do pay attention because you know where, like if you're playing ball, the ball is gonna behave a certain way, but that is expected. Um, so in astronomy, it's pretty usual that you move the electromagnetic spectrum, the range, not only slide back and forth, but also use different ranges of that of those waves, from the very low energy to the very high energy, from gamma rays to microwaves and infrared. So this is the same image. Like if you have a telescope, the Crab Nebula would not look very exciting. It would look just this little blob with some structure. But if you change the signal, the waves that you can see, and also stretch it or compress it, you start seeing more of these very delicate structures inside this exploded star, which is what the nebula is. So of course, if we were to scale that back down, if we were just like, I'm not an astronomer anymore, but I'm gonna be a regular person, I want things to happen just like what I see out in space. So in a space, astronomers are looking at the stars, and when they tint a little bit blue, that's because the wave is being compressed. So you're seeing more waves in the, as time progresses, as a movement progresses, that are being compressed. So that compresses what you see. Therefore, the car would look blue because it would slide into the blue part of the electromagnetic spectrum. And then the opposite, when the car is moving away, the wave will stretch as it moves away. So the farther it goes, the more red. The faster it moves away from you, it would look more red. So that's what is the redshift. Not a natural experience for humans. And of course, we have a situation where we are on planet Earth, and we are very, selfish species, and we form groups, and we think of perspective from the point of view of like a personal experience, but also with the groups one identifies with. But then as that scale changes, so does the rules that govern those scales. So we are in, little planet Earth over here, tiny little dot. But no, this way, no, that way. And what seems to affect events at the human scale is not the same that affects event at the scale uh, of planetary scale. Because if that was the case, we would end up in a situation where the planets that we scale for a certain visualization, if that was true, we would end up with some absurdity where it's like we could have a picnic and with another planet just like 4 feet from us. It could be exciting, but a little uncomfortable maybe. Um, and then the things that happen in space over time that affect these stars and galaxies, we may not afford to see them because they are all moving to a speed that we cannot detect. Well, we don't see mountains moving, and imagine this is a different scale of dynamics, but they are moving. It's just that, we are on little planet Earth, and like person in a plane, we can't detect the motion then, but actually they're moving really fast. You can look that up. It's like really, really fast. Um, but if we were to give a command to this little dog and say, stay here, and the dog was super obedient, we would see the dog, flying into space. Things are moving. Uh, it's just a matter of detection. Let's see. So So in creating visualizations too, why we do those is to understand the events at those bigger scales. So things like understanding the melting of the ice caps over time, which is what this NASA Goddard visualization shows. You have to see the cycle happening over and over. And of course, we have satellites taking pictures. So we do have the beautiful images from the blue marble showing this that can show the change that we would not see. I mean, we barely feel the seasons, right? Uh, but that is what the visualizations afford. But they need to be scaled to our perception of time and change. Um, but of course, if we had, let's see, moved away, a situation, when I was at the Adler, I was giving talks to the public on scientific visualization, and that was a very good example of things. We have the Andromeda galaxy, which is the closest galaxy to the Milky Way. They are kind of gravitationally bound, so both galaxies, like it has happened in the past, they're gonna eventually merge and become one galaxy. But of course, this won't happen in a time scale that would be something that we can experience. Like by then, there may not be Earth or solar system, so we may need to find another place to move. So you do have that time scale that can be compressed to understand the phenomena. In this case, it's a 5 billion year that it would take for the two galaxies to be merged. And the way it has been, this visualization has been created is by looking at the data on how fast both galaxies are moving. And you also have at a much bigger scale, the situation where we can actually map where galaxies are, and then we can look at them not just from the point of view of Earth, but from that experience of walking through those galaxies to try and understand something of what's happening with them and why they are forming the structure that we see today, which is like a foam bubble structure. Where galaxies are all squished between the bubbles and forming little clusters as they group together. So here you have the very well-known Big Bang to present. Here's the Big Bang, and this is today. And we have the situation where what we're seeing, the farther in space we look, the more back in time we see, because the speed of light is limited to us. So the universe is sort of like our body reaches, so we do have what our senses can reach in terms and what we can afford with the time we have and the physics of the universe itself. Um, but then, of course, what that brings us back to is the assumptions we have about our own planet. And I thought it was interesting to show you something that was quite shocking for me. And I worked in Hawaii in 2016, and here you have me in that picture in a beautiful place called Kapoho, snorkeling. That maybe some of you have been there. Uh, but if you look at that house, is that house during the volcano eruption. Uh, it was overtaken by lava, and this is how Kapoho looks now. It's all covered under at least 8 feet of lava. Oops. Let me put my power. Um, so for me, it was interesting because I had a certain assumption of how a space should behave and how land should behave, not changing because it should be stable, but it is very dynamic. So it is changing, and it is affected by natural phenomena as much as it is affected by uh, things that we do there. So it's a lot of assumptions, right? That we have this body that is becoming the media itself, or VR is helping us look at the body with this light that it is determined in some ways like any other media. And then we have the human unbelt, or the human world that we have, and the fact that we are inhabiting the universe formatted through our experience of the human body on planet Earth. So the models we create not only come back to our body, but we are looking at them as if they were an extension of our body. So there's some kind of adoption thing going on there in this extension of our senses and our motricity. Um, and along the way, it's also interesting in the sense that you have climate change, which of course is responding to human population actions. And then that, which is something I wrote in the book that appears in my biography, is also part of that learning, that understanding not just extensions, but the consequences of our actions en masse that we cannot detect out of a personal experience, but we have the data to detect on how many people doing the same bad thing reflects on a consequence in the environment itself. So there are these things to consider. So how does working in the dome happen, or what does it mean? Well, the cave is a research, the research devices, but you have the planetarium dome where anybody in the city can visit and be in a situation of not knowing much about astronomy, but feeling immersed and feeling that the universe is mapped to your body as you sit in that chair looking out into space. Not only and not only navigating the cosmos, but sometimes it is like looking at the stars, which are, children don't see in Chicago, but they can see in the planetarium dome as if there was no light pollution. So there's this extension of our experience that may derive from, again, our actions in the environment. Um, this is a piece that I was in the team developing it, but I wasn't, I didn't make this piece. It was a design company in Chicago. But I did work on it in the sense of developing on what we wanted. This was the Cosmology Gallery at the Adler. And what you see here is like a trip to time, very much like the tunnel that I showed you before, that shows like looking back into space is the farther back in time of the history of the universe. So what you have in this tunnel is the early universe, where you have, the primordial soup, if you wish, in the first interactive on the floor. Oh, by the way, it was going to be on the walls, and I said, but why not on the floor? It would make more sense, and it actually worked really well for kids who respond to things they can touch and walk upon. So you have the primordial soup in the first station, then exploding stars, which actually made more of the elements that we have today, like the iron in our blood and whatnot. And on the third station, you have the action of galaxies merging, but like how galaxies are bound with the dark matter uh, and respond to that. So, so this was an experience in steps to understand this back in time history in a very physical way. We also, the thing I work more on was we made a little tour with AR graphics attached to the timeline that you see here in this wall. And I did some of the visualization on the other wall, showing how particles behave and whatnot. So, but it was part of this process. It's like, how do you reconstruct this unreachable universe? So a lot of the work or the projects that I was involved were about this deconstructing the human body and reconstructing it into an experience of a museum for visitors to understand some aspect of how the universe is in a way that was scaled to their body. Another thing that I was involved with, actually, I asked Todd Margolis and Tracy Cornish, former EVL students also, to curate an augmented reality exhibit in 2012. Um, so that the way that work is they came up with a concept called moonlust, and I speculated on what would happen when we start populating the moon. So different people did different projects that would come up through your phone as an augment of an exhibit or the places surrounding the atlas. So one of them was in the middle of the lake. There were some pieces outside and another one to the right over there. Uh, so again, this deconstructing of space, putting back together, map it not just to the human body, but in this case to the space of the whole museum. And this piece by Robert Rothab was something that we actually had a piece at the museum on looking at cosmic rays, but at different altitudes, because as you move out of the planet's atmosphere, you are more victim to more of these cosmic rays. In this case, Robert took that idea and put a space elevator in the middle of the lake here, well, in the middle between Navy Pier and the Adler, where you would move up. So there was a station that popped up in augmented reality, and then you could see the elevator moving up in the middle of the lake, operating this station. So it was a lot of fun. And Brenda Lopez, also a EVL alum, she came up with this idea of a roller coaster in low gravity on the moon. And the roller coaster was mapped onto a 1940 model of the moon that has been in the Adler forever. So people could operate, like moving their tablet or their phones, they could see how this low gravity roller coaster was working. Another way I try to help deconstruct the experience of scaling space and mapping it to a body was I invited Miwa Matrejak, who does this thing about she stands in the back of the screen and her shadow is projected onto these animations that she's created. So at some point she may look like a giant, or she may look like a little tiny thing, and her body size would change depending on how far away from the screen she is in the back. And also she would, to do things like uh, lean back in a couple chairs so it looks like she was swimming or floating, so she puts her real body in real time, for people watching the performance, with all these imaginary worlds, and does things with her hands, and she mapped her like the animated her hands in front of the shadow of her hands, so it does look like she's involved in this world. But what was interesting to me was this projecting the body into all these different environments, and to have, I wanted to have the other staff at Adler think about that. Another piece that this was not really interactive, but it was what the one visualizations I showed earlier. That was by Miguel Ángel Aragón Calvo, who worked very closely with Mark Subarao, the director of the laboratory. And so we work with him quite often. And one day he came and wanted to send a poster for this National Science Foundation Visualization Challenge. So I thought I would show it because what you see here is not only that it's a matter of space in terms of how we are looking at the cosmic web, the structure of how galaxies are distributed in space, but also what ranges, what scale, what resolution. In this case, these little rectangles you see are what each of the visualizations see, the n-body simulation of the cosmic web that he made. He just gave me a full folder with all the different colors and all the different uh, aspects of the cosmic wave that he was thinking about. And I overlaid them together to create, this kind of progression. But what you see there is the uh, the bubble structure at 5 different resolutions. And in the next step, and this poster was in the cover of Science Magazine. Anyway, what you see here is this bubble structure uh, just shown as a boundary, like a veil boundary. Um, in this one over here, they look like little wispy things, but what he wanted to show is how, as gravity accumulates in certain areas of space, uh, matter that was going one way gets distorted, attracted to where gravity is stronger. So you have matter moving not just straight out, but depending on how, uh, what is accumulating more mass. Uh, Over here, you have a visualization showing where scientists think that dark matter would be. So it's just showing the dark matter distribution, like making more visible this cosmic web. And over here, uh, what you see in the last section is the galaxies themselves, but Miguel Angel scaled them about 10 times as big, so they would be visible for the poster, which is something you forget too, that things in space are really, really far away from each other to such an extent that you wouldn't really see anything if you were a giant capable of seeing, having the actual. So, see, and this is a visualization by Miguel Angel. And this is a piece that was the design of an interactive to present uh, the program that another EVL alum had created, Bob Koima, um, who got his PhD from EVL. And what my task was at that point was to develop an interactive for the gallery so people could experience what he had created in being able to look at that terrain in very, very high resolution with a lot of detail, and in a very interactive manner. So this was again another exercise of deconstructing the senses, from being able to choose where to go, but the experience of visitors in the gallery. Um, so in a way that when the person that chooses where to go goes to that place, the panels at the top of the display would tell everybody in the gallery what they were looking at. So it took, it was a little bit like imagining what you would see if you were in a spacecraft, with the displays being a little bit tilted, so you would have that sense of flying over, uh, a lot of immersion because of the scale of this display, uh, but also the participation of the other visitors in the gallery, so they would have an understanding of where they were with the map. You can see there's a little map of the moon that kind of rotates and show you where in the moon you are flying. Um, and then what feature is being shown, and what is the location, what do we know about that particular place. So again, like a deconstruction, reconstruction of the experience, not just for one person, but for visitors, and with some degree of agency of the person navigating. Um, then wanted to show this deer animation. So the Adler has one of the top collections of astronomical instruments and books. It has, originals by Galileo and Kepler and lots of things like that. So this is what you saw before is a drawing by William Herschel and how he imagined that the Milky Way looked like. From seeing it from the ground, it looks like a band, right? It looks like this line of like clustered stars. So he said maybe the Milky Way looks like that. And this is another illustration by Thomas Wright, where he said, well, maybe our galaxy is just stars sitting in the surface of a sphere, and the other galaxies we see are, just uh, other spheres. So what I did here we did some stereoscopic images to kind of test what, if a stereoscopy actually help people understand 3 dimensions. So this was one of the few things that we showed them. So you can see when you zoom in to the surface of the sphere, it does look like a line of stars. So actually, the study that was led by Dr. Aaron Price, who works at the MSI now as a lead educator and researcher, what the studies show with the evaluation right after and a few months later was that people that saw the stereoscopic version of the movies with showing these models actually retain a significant, stronger recall of the understanding. So the 3D actually anchored the memory much better. So the last part that I wanted to share on this deconstructing and putting back together was a couple things that I work uh, since I'm not at the Adler. Um, so when I went to work to Hawaii in 2016, as I was writing my doctoral thesis, I was still, thinking of how we are interacting with these models. I was invited by Jason Lee to be in a collaborative class with computer scientists, other artists, and marine scientists, and we did interactives. We had the students work together in transdisciplinary groups uh, on projects, in immersive projects that show uh, research about corals in Hawaii. And after that, or during that, I was invited to teach a summer class. Um, and the director of the art department said, I want you to teach something about VR. Oh, by the way, I had taught something at the Art Institute. So I said, something like this, let's think about it, because if it's collaboration, it's a lot more fun. So he said, well, we have a printmaker that would teach also as a team, but we need a third person. And I said, well, what about the sculpture, to kind of look at the 3D from the hands of someone who works with actual solid objects, tangible objects. So he came back with the name of Monica Mann, who's a ceramist. So we had a ceramics professor, a printmaker professor, who was John Goebel, and then me doing VR. And we met and developed this class where we had the students work on the clay, creating these 3D models, then scanning them and printing them in 3D at different sizes. So there was some sense of a scale and how the objects change when you do that, or your experience of the object changes. And then in the VR part that I was leading, we got a Vive system, and we set up a big screen so the rest of the class could see what the Vive-tied person could see. And my challenge to the students was to take this model, I showed them how to put it in Unity, and then be able to either walk through or walk over the object. So the object had to be really, really big. So of course, perception changes. Your whole experience changes because the object is not the one fixed scale. So you can compare what happened when you are scaling things that way. So that was a very interesting thing. And of course, people that do movies, they're working with 3D models, they're touching things, and then those things get scanned. So it is a similar process, but in this case, we did show like the universe visualizations and had them think about that too. And we also had them take their phones and do time lapses or slow motions of things that were around in the island. We we visited the caves, the lava tubes, how those were these kind of very immersive spaces, of course. We also visited tree molds. So when the lava comes through a forest, it goes around the trees. The trees offer some resistance, but then the tree burns and it leaves behind a kind of inverse 3D print of what the tree was. So that was another aspect. So we look at all these different ways in which events happen at different scales of space and time, and to be experienced by the body in a different way. So this is another student, using the Vive to look at the models, and another student moving around these arches that she made. It was about this big of these arches that she molded in clay. Did have a little component of motion. We had some particle animation there to think about time as well. Another project, when I came back to Chicago, well, in Hawaii, I saw that this application called Literati had been created. Someone had started, Jeff Kishner in San Francisco had started taking pictures of trash in the street and putting them on Instagram and doing Google Maps. And eventually that became its own application that allows you to take a picture of the trash wherever you find it. So it geotags it, and then you can say, is it plastic? Is it a certain brand? What kind of object it is and whatnot. And I wanted to do this in my neighborhood because we live here for 20 years. So I had some idea of the litter in the street, but I did this, of course, there's an environmental reason, but also to think about how we map that data to our experience. How do you feel when you collect this data and you did it yourself? So when I was at the Adler, I saw and I work along people developing a Zooniverse, which is this online platform that allows non-scientists to help scientists in doing things that computers cannot do, such as recognizing, telling galaxies apart. Is it a spiral or is it an elliptical galaxy? And it has done all other kinds of classifications, especially for things that are difficult in artificial intelligence and that kind of thing. So so I had this idea, well, that data is given by the scientists, but in this case, the data is generated by the people that live on Earth, looking at the environment that is there. So, so that's something that I wanted to think about and reflect. And here is, since people don't like looking at trash, what I did is I took the about 6,000 pictures that we took last year, and I overlaid them on this part of like a historic postcard of Forest Park, which is where we live. So all these little things are the pieces of trash that were collected. So people would look at them. Oh, and I talk with different businesses, the library, village hall, and different bars. There's the hardware store, the cookie place, and I arrange for to have like like a mini traveling exhibit. So two weeks at a time, uh, this image would be displayed in one of the businesses to reach the different kind of people that visit each of them. Because not everybody goes to every one of these places. So I figured this was a way of putting back in consciousness this thing that we kind of ignore because it's just too much or we're busy. So, and then another thing I worked since is I had never done pottery. And last year I started working in pottery a little bit out of the project that I was showing you in Hawaii. Um, Working with in this case, motion in the wheel and playing with the physics in a very direct manner. As you turn the wheel, you can change the speed, you can press more firmly or slower or whatnot. So I work in pottery making these, I call them haptic stations because they are touchable visualizations. And I also work with the color. So you see, so I had an idea of how the color would work when the glaze is, it melts into a shape. Um, so there's, oops, the piece you see there, oops, was this one. So you see it, you move your finger as it rotates and you get this structure. So that's about it, to keep on thinking of how we deconstruct our body and construct these other things. This is another insights of one of the playthings that I made.